All right, guys. So you just spent some time watching a video and learning about parabolas and quadratic functions and what all that stuff is. So now I'm going to go through and I'm going to show you a little bit more specifically um, how to find different parts of a parabola, of a quadratic function. So the standard form of a quadratic is ax squared plus bx plus c. Just like linear functions have different ways of being written, quadratic functions have different ways of being written too. And this is the standard form. This is the most common form that you'll see a quadratic function be written in. Okay. And when you graph a quadratic equation, just like a linear equation makes a line, a quadratic equation will make a U-shaped curve, and we call that a parabola. Okay, so let's take a look. Pull out your calculator for a second, and I'll show you what different parabolas look like. Okay, so when you go into your graphing calculator, something that's kind of cool is if you hit the y equals button, clear it out, I can type this equation into my calculator and it'll graph it for me, which is kind of cool. So if I hit the X button and then squared plus 2x minus 5. And then up here at the top right where it says graph, if I hit the graph button, it's going to show me generally what my parabola is going to look like. Okay. Now, if your calculator doesn't look quite like mine, you can hit this zoom button and that's going to change the size of your box. So I think I hit standard for mine, and that's what's going to show just like the big coordinate plane. That's going to give you a nice little parabola there. So what we notice here is that our parabola is opening up. It's making a nice U shape. And this turning point is over here on the left. We'll talk about what that turning point means here in a second. But in general, my parabola is going to look kind of like that. Okay, so you take a second and I want you to try to go back to this parabola over here. See if you can graph that one in your calculator on your own. Okay, if you did it correctly, notice this parabola has a negative in the front. So let's see if that changes anything. I'm going to make sure I hit the negative button down here, not the subtraction sign, but the negative. X squared plus 3x plus 7, and then I'll hit graph. So this time we notice that my parabola is upside down. It doesn't make a U anymore. It makes kind of a frowny face, okay? And the reason for that looks, kind of right. Not so much, but that's okay. This is just a sketch. This is not exact, okay? So the reason that my parabola is upside down in my second one versus my first one is because of my a value, okay? The a value is your coefficient of your x squared term. So if my a is positive, just like in my first example, then my parabola is going to open up like a smile. Whereas if my a value is negative, then the parabola is going to open down like a frown, and that rhymes. So that's super easy for you to remember. Hopefully you can remember that. Positive, it opens up because positive people smile, and negative, it opens down like a frown. Womp womp. Okay. So there are different pieces to our parabola. Okay. If you notice in my first one, this drawing's a lot better than my other ones when you use this one. If you notice, if I were to draw a line through the middle of my parabola, it's almost symmetrical. The real one actually was symmetrical, right? And that place where we can draw this invisible line that cuts it in half is called our axis of symmetry, okay? We're going to say that's the invisible line that cuts the parabola in half. Okay, that's what makes it symmetrical. It makes it the same on both sides. So when we're in standard form, again, that's the ax squared plus bx plus c. When we're in standard form, we can use the equation negative b over 2 times a. That will give us our axis of symmetry. That's going to tell us, excuse me, that's going to tell us the x value of our vertex, okay? If you don't know this word from the video we just watched, vertex is like the important thing about a quadratic function because it is the turning point of the parabola. That's like the key point that we need to be able to find is the vertex, okay? And the cool thing about the axis of symmetry and the vertex is that they're related to each other because my axis of symmetry is the x value of the vertex. Okay, see how my line goes through this turning point here? That's the x value of my vertex because it's going to have an x value here. It goes through the x-axis at some point. Okay, so when the vertex is at the lowest point, that's called a minimum. That's the smallest value that the parabola can possibly have. And when the vertex is at the highest point, the opposite of minimum would be the maximum. So that would be the highest point that a parabola could actually have, okay? So let's find a few of these, okay? If I've got the equation x squared plus 8x plus 15, the first thing I want to be able to find is my axis of symmetry, the x value of my vertex. So I'm going to do x equals negative b over 2 times a. Okay, and again, my standard form is ax squared plus bx plus c. So my a value is the coefficient of my squared term. My b value is the coefficient of my x term. And my c value is the constant, always. Those will never change. So when I go back here, x equals negative b over 2 times a, well, my b value is 8. And negative does not mean it's always negative. It means we use the opposite sign. So the opposite sign of positive 8 is, of course, negative 8 over 2 times my a value. Well, is there anything in front of the x squared? Yes, there's a positive 1. So negative 8 over 2 times 1 would be negative 4. So my axis of symmetry is the line x equals negative 4. Okay, so then to find my vertex, well, I just said the axis of symmetry is the x value of my vertex, and my vertex is going to be a point. It's going to be the turning point. And whenever I have a point, I need two values, an x value and the y value that I get when I plug in x. So what I can do is I can plug the x value, my axis of symmetry, back into the equation, and that'll give me the y value. So if I've got y equals negative 4 squared, I'm going to put negative 4 in parentheses and then square it because I want my calculator to read this as negative 4 times negative 4. Then I'll do plus 8 times negative 4 plus 15. Okay, now I can do this in my head. I can do this in my calculator. Probably your teacher's going to want you to put it in to figure it out yourself. But for the sake of time, I'm going to plug this in here because I want to show you something. If I do negative 4 squared plus 8 times negative 4 plus 15, that's going to give me negative 1. Now, if I didn't put the parentheses around my negative 4, if I just did negative 4 squared plus 8 times negative 4 plus 15, then my calculator gives me a different answer because In my first one, it reads it as negative 4 squared. So that's negative 4 times negative 4. In my second one, it reads it as 4 squared times negative 1. 4 times 4 is 16 times negative would change it to negative 16, whereas this one is positive 16. So it gives me two different answers. My answer, of course, is the one that I did first, negative 1, because the calculator read it appropriately. So my vertex then is the point negative 4, negative 1, okay, because my y value was negative 1. So when I sketch this is not going to be perfect by any stretch of the imagination, okay, but I know that my vertex is negative 4, negative 1, so that's going to be somewhere over here. And I know that my equation is going to open up because I have a positive a value. So it's going to look something like that. Okay, let's try just a couple more together. Flip your paper over. Let's look at number 2. Okay, I want to do my axis of symmetry first. Again, that's the x value of my vertex. So I'm going to use the equation x equals negative b over 2 times a. And yes, that's something that you will need to memorize. So negative b is the opposite sign of b. So in this case, that's negative 10 over 2 times my a value, which in this case is the coefficient of x squared. So that's negative 1. So negative 10 over 2 times negative 1 is going to be positive 5. So my axis of symmetry is x equals positive 5. Okay. So then to find the rest of my vertex, I need to find the y value. So what am I going to do? I'm going to plug 5 in for the x's. Okay. So again, I need to be careful because I've got this negative out front, but is my x value negative? No. The negative is part of my equation, so I'm going to leave it the negative outside and square the 5 plus 10 times 5 minus 23. Okay, so when we do this, we have to think, okay, 5 squared is 25 times negative 1 would be negative 25 plus 10 times 5 would be 50 minus 23. Okay, well, let's do this. We can handle it. Negative 25 plus 50 would be positive 25 minus 23 would be 2. Y equals 2. So our vertex is the point 5, 2. Okay, so when I sketch this, again, this is not going to be exact, not going to be beautiful, but I know two things. I know that my vertex is the point 5, 2, and I know that my parabola is going to open down because of my negative a value. So that means my vertex 5, 2 is going to be the highest point on my graph. So it's going to look a little something like that. Okay. All right. Let's skip down to number 9 really quickly, and then I will let you do your own thing. Okay. What do you notice about number 9 that's different from the other equations we've done? Hopefully you noticed that it's missing one of our terms. Okay. This time it's actually missing our b value, our middle term. I've got my squared term and I've got my constant term, which means I'm missing my middle term. So when I find my axis of symmetry, negative b over 2a, well, if my b value is not there, what number is it? It's going to be 0. So I have 0 over 2 times 1, which of course is just 0. So my axis of symmetry is x equals 0. Okay, so then I'll plug 0 in here to find my vertex, y equals 0 squared minus 3. Well, 0 squared is 0, minus 3 is negative 3. So my vertex is the point 0 and negative 3. Okay, well, if I'm going to sketch this, my parabola is going to open up because my a value is positive and my vertex is 0, negative 3. So this is actually also going to be my y-intercept. because it crosses the y-axis where x is 0 and y is -3. So my vertex this time would be the same as my y-intercept. Okay, go through and finish 3 through 10. Good work.